Hey, this is Pius. Just wanted to give you some great news before the episode starts. If you haven't heard, the podcast will be at South by Southwest this March in Austin, Texas. So Rachel and I will present some hands-on workshops for educators and professional engineers. Look us up for more details. And if you stick around to the very end of the episode, you might get a teaser of what's in store. This is the K-12 Engineering Education Podcast for November 7th, 2016. What's your favorite ice cream?
I'd always say chocolate chip cookie dough.
Probably we have like an orange chocolate ice cream that tastes like those chocolate oranges that you get at Christmas.
When I go place to place, I will try their salted caramel. That's my benchmark ice cream.
I honestly just enjoy a good bowl of plain vanilla ice cream.
So many people love ice cream, including students, and including me, your host, Pius. For this episode, I wondered how you could take something so ubiquitously enjoyed, like ice cream, and use it to hook students into engineering. A trip to my local ice cream factory helped me sort out my thoughts. Let's start with two engineering challenges. The first one is a challenge of imagination. If you could create and have any ice cream-related technology or product that you wanted, what would it be? I asked this to Natalie and Frankie, two workers at an ice cream shop in Austin.
I'd have to say an ice cream scoop that you never have to put in water so it gets warm enough to cut through. I know it's out there somewhere, but I can't find it yet.
Making ice cream with like dry ice, like maybe in one of those whipped cream containers or something so you can make it real quick. I don't know. I think that'd be really cool.
Like a spray ice cream kind of thing?
Yeah, I think just like freezing it real quick so it's like that consistency.
Whipping cream, what flavor you want, and then able to quick freeze it.
Oh, right, like you see on the Food Network, those giant machines.
You can do like custom flavors and stuff or something like that. I think that'd be pretty cool.
Awesome. Okay, thank you. Those are neat ideas, and Natalie and Frankie came up with them pretty fast. Maybe they think about ice cream more than the average consumer because they work with it. Could students come up with creative ideas quickly? Could you? The second challenge is a big old design challenge. Suppose you have 12 ice cream shops located all around town in Austin, Texas, spread out across 20 miles of the city. And you have to supply ice cream from your ice cream factory to all 12 stores every day, even when the traffic is bad and the summers are hot. How would you design your system to supply all your shops with delicious, perfectly frozen ice cream all the time to keep your customers happy? We'll revisit these challenges later in the episode. For now, to learn more about ice cream, let's go to the ice cream production facility for Amy's Ice Cream in Austin, Texas, to hear from an expert.
Hi, my name is Joe Morris. I do purchasing and production for Amy's Ice Creams, and I've been an ice cream man for knocking on the door 20 years.
Joe started at Amy's Ice Cream back when he was attending the University of Texas at Austin, and he was even certified to become a Latin teacher. But upon graduation, he was having so much fun that he stayed at Amy's.
We're a kind of a small but local ice cream company out of Austin, Texas, started by Amy. She's my boss, still runs the company to this very day. If you're coming in to enjoy ice cream, it's usually because you're celebrating something. You're treating yourself, or it's a birthday, or you got a good grade on your report card. Or conversely, if you've had a crummy day, if you walk out your front door, you stub your toe, and your day rolls downhill from there. Ice cream is kind of a socially polite and acceptable way to pick your spirits up. Ice cream is what we make, but what we're really selling and what our main product is that memory. It's the enjoyment that comes with eating ice cream. And so our company motto is to make people's day. Ice cream is just kind of the vehicle by which we do that.
Following this bigger mission, Amy's Ice Creams grew from the original store in the 1980s to now 12 locations across Austin in 2016. Suspiciously similar to the design challenge I gave earlier, I know. And today, all the ice cream is being made here.
This is where we make all the ice cream. We do what's called small batch processing. It means we make one batch at a time.
Joe gave me a tour of the white-walled Amy's production facility, with machinery constantly humming under the high ceilings and people working at their stations.
See what this one's not running right now, but basically it's just a big metal tube, and then this is a stirring mechanism that you put in, and you slide it in there, and it stirs and kind of scrapes the walls.
Joe was describing a few large stainless steel machines against the wall that were constantly stirring and freezing ice cream. Even though these were small batch machines relative to bigger factories, they still make many gallons more ice cream than your home ice cream maker.
The product, when it gets to kind of a frozen point, is about 26 degrees Fahrenheit. To ice cream, that's actually a pretty warm day. In fact, it looks like she's about ready to pull out a fresh batch. You see, it kind of comes out a pudding soft consistency.
Then Joe pointed out the really tall blast freezers on the other side of the room. They put the soft, freshly churned ice cream in there to harden overnight.
Tomorrow, it'll be frozen at that, negative 25 degrees, and then it'll be ready. It'll be the finished product of ice cream that you're used to now. At 26 degrees, negative 25 degrees, it's too hard to scoop. You couldn't get a spoon in there, so you kind of temper it back up to a warmer freezing temperature. About negative 10 to 0 degrees Fahrenheit, which is what most standard home freezers are at. So this is actually our cake department. So what they're doing is they're actually building and decorating cakes. Because what we do is we take the soft ice cream and we put it into a cake pan, one of these, and kind of makes a little hockey puck of ice cream. And then they take basically 2 equal-sized pieces of cake and build kind of a big cake and ice cream sandwich out of it. So put some cake down, put a little fudge or maybe some praline sauce, kind of act as a little sticking agent, a little extra insulation, and another piece of cake. And then the ice cream's kind of sandwiched there in the middle, and they fresh whip some frosting, and then they frost and decorate the cakes. And what happens is the cake and the frosting all act as insulators to the ice cream. That way the ice cream doesn't melt. Kind of gives them the chance to decorate, and then they can freeze the cake when it's over, and that way it doesn't just kind of leak all out. That's the one thing you're kind of always having to consider is kind of that thermal exchange of keeping the ice cream cold until the point that you want to eat it.
On this tour alone, Joe already gave several interesting ideas for integrating ice cream with engineering class. You could base some thermodynamics lessons on getting ice cream to the right temperatures or insulating your ice cream cake with just the right amount of frosting. Maybe they have to design the water circulation system for cooling the freezers. You could say the ideas were churning in my head. Joe showed a lot of the machines and processes of the Amy's production facility, but there was also a lot to say about the ice cream itself. Amy's likes to call it good mood food, but what is it really?
Ice cream is about 60% water, and then it's about 15% of sugar or syrup solution. The sugar's there to add the sweet flavor that people enjoy, but physically, what it does is it makes it to where the ice cream freezes a little easier. It depresses the freezing point of the ice cream so that it's able to be kind of that soft, ball of ice cream that's edible, that's not crunchy. Again, if it's 60% water, you take anything that's 60% water and you freeze it, it becomes basically just a big chunk of ice, and you can't stick a spoon in there, you can't eat it. But the sugar mixed in kind of makes a solution, and then you also have some milk protein solids, usually about a 10% of the milk protein, and then anywhere from 10 to 20% butterfat content. And between the sugar and the butterfat content, you have most of your flavor, but you also have the 2 things that help you take that water and make it to more manageable ice crystals.
So to review, Joe gave the rough formula of ice cream being about 60% water, 15% sugar, maybe 10% milk solids, and the rest being butterfat content for flavor. We also know that good ice cream that's smooth has as tiny ice crystals as possible.
So the kind of three main science things that you can do to that is control kind of the emulsory properties. So it's the butterfat and the sugar, and sometimes you add other natural emulsifiers like egg yolks or some gums like vegetable gums or pectins. And then the other thing that's in there is the air bubbles. When you're stirring the ice cream, you're kind of naturally whipping a little bit of air in there. Some ice creams will have pretty high air content. We're what's considered a super premium ice cream, so we actually try to keep our air content as low as possible, but we have a higher butterfat content, so it's get more of the good stuff and less air, and still trying to make a really small crystal creamy ice cream.
If you haven't seen what ice cream looks like under a microscope, you should Google it. You can see the mixed pockets of ice, fat, and air in the ice cream emulsion.
Trying to freeze the ice cream as fast as possible and stirring it while you're freezing it is the best way to not only get that air in, but also get those ice crystals as small as possible.
So to get tiny ice crystals, you can mess around with a formula, and you can also freeze as fast as possible while mixing air in. This already sounds similar to the classic chemical engineering techniques of designing products and processes. The product here being the ice cream mix, and the process being how you mix it all together and freeze it. When talking about how Amy's comes up with new flavors, Joe described what engineers sometimes call adaptive redesign. They start with an ice cream recipe that they know already works, and they make changes and additions starting from there.
We start off with a base mix that is made to our specific recipe. It's just milk, butter, sugar, and eggs, and it basically is our sweet cream ice cream. So we have a flavor we call sweet cream. It's basically unflavored ice cream, but that's the basis for every single flavor we build off of. And then beyond that, we know how to build a recipe. So to make vanilla, we add vanilla. To make chocolate, we actually cook in chocolate. To make strawberries, we chop up and stir some strawberries in there and make strawberry ice cream. I have a joke that I tell kind of groups of kids. I say, if you want to make banana ice cream, you just peel a bunch of bananas and you mash them up in there and put them in the milk. You have banana milk, freeze and stir that banana milk, and you'll get banana ice cream. If you want to make peppermint ice cream, you put a little bit of peppermint in the milk, take your peppermint and milk, stir it and freeze, you get peppermint ice cream. I mean, I could take my shoes off my feet, chop my shoes up, stir my shoes into the milk, and we could make some shoe flavored ice cream. Now, whether or not anybody would want to eat it is a full other question, but we have the ability to make the shoe flavored ice cream.
They've been doing this long enough that they also know some boundary conditions for their ice cream experiments.
We do measure and we do build recipes, and you kind of know what parameters to stay within. Because if we tried to make Oreo cookies and cream ice cream and use too many Oreos, if we use so many Oreos that you didn't taste any ice cream actually in there, it was just a bunch of frozen cookies.
Right.
Again, your proportions are off and you're not enjoying it. So it's kind of knowing like you need at least this much. So again, you want every bite to have a little bit of Oreo cookie in there, but you don't want to have a full Oreo in every single bite. And so it's kind of finding that's where you kind of work within here's my window and here's too much, here's not enough. And so I need to find somewhere kind of really happy right there in the middle.
Testing and data are critical when evaluating their ice creams.
When we get a new flavor, we send it out to a store and we actually engage not just our scoops and everybody in the company, but a lot of our stores will be kind of our test kitchens. And so they'll say, hey, there's a brand new flavor we're beta testing here. Yeah. And we'll have we'll basically ask each customer that comes in, hey, can you help us sample this? And tell us what you think. We'll have give them a taster spoon of the flavor, and then we have two buckets. One bucket says yay, one bucket says nay. Hey, this is a good flavor, yay, let's keep it. You know what? Not my cup of tea, nay. And you get really good, honest feedback. The people who are going to be enjoying it are the customers, so you definitely want to engage them as early in the process as possible. Sometimes the flavors that we learn the most out of are the ones that don't work. I always think, probably the first person to ever pick a vanilla bean off a vanilla bush and eat it, it tastes terrible. A vanilla bean does not taste very good. It's very bitter. It pulls the moisture out of your mouth. it probably, I think about thousands of years ago, whoever first tried it probably thought it was poisonous. It just doesn't taste very good. Okay. But you take vanilla and you soak it in an extract liquid for, kind of make a tea out of it and let it sit there for a few weeks. All of a sudden you have vanilla extract. And we put that in every dessert that we can think of. I mean, it's in cakes, cookies, brownies. It's one of the most popular desserts out there. So sometimes it's finding that weird ingredient and finding an interesting way to develop it to something that people love.
Just as in engineering, they learn from when they make something that doesn't work, too.
Failure is a lot of times a good thing because you realize, okay, next time when I do this, I'm not going to do that. Man, I put a lot of cinnamon in this flavor, and the cinnamon was so strong that it overpowered all the other ingredients. People aren't going to like it. Next time, I'm going to go cut the cinnamon in half and see what that does.
All of this information from testing is recorded to help them judge new flavors and keep quality control for old ones.
Our store managers actually, part of their software that they have on their iPads at their stores is one of them's a review form though that basically, hey, this is a new flavor, and they know to do it for the new flavors. But even if it's a flavor they've, a regular standard flavor that they've had a lot of, and it's off for some reason. Mm-hmm. They can give us that feedback. They say, hey, this batch of vanilla dated this date, it tastes a little bit off, here's what I'm tasting, and then we can go back and kind of figure out, hey, what happened there? Was it just a fluke? We know everything that was made on that day, kind of the whole schedule of what was made, and we can kind of backwards track and say, okay, here's the things that could be. It may not be the exact answer, but it may be like, oh wow, that was so-and-so's first day working. And you expect to have a few mistakes on somebody's first day just as they're learning the system. So maybe they didn't, read the recipe correctly, or maybe they're still, kind of nervous and spilled something. But it allows us. Or conversely, if it's, hey man, this batch of ice cream I've had it 1,000 times, and today's batch was just amazing, out of this world. Whatever you did different that makes it amazing, please repeat that. And it can even be something as simple as, we know that on days when there's not a lot of humidity in the air, the ice cream making process is a lot easier. The ice cream turns out better because you're not, again, pulling that extra moisture into the air. So the temperature and the humidity and affects us. On rainy days, the ice cream making is a little bit harder. It goes a little bit slower because you're kind of fighting the humidity in the air. Just making sure again, what the process was, why something turned out great or why something didn't turn out how you want it to, and being able to account for that or correct it or change it or anticipate it and balance it out with something else.
Joe said it's important for Amy's to keep on producing new flavors for different neighborhoods. How does Amy's come up with them?
In a normal month, we'll produce about 300 different flavors of ice cream, and kind of always try and do ones and send new ones out. So when it comes to designing a new flavor, we do have a process. So it's something as simple as find the germination of an idea. Somebody wakes up and says, oh my gosh, I've got it, here's the best new flavor, and or taking two opposing flavors and finding a way to put them together. And so we often have brainstorming sessions where we'll just sit around and say, hey, next week at our meeting, everybody comes with 2 new ideas or 2 fun ideas, and you get everything from something really, kind of very gourmet and fancy to, how come we've just never added chocolate chips to this?
So they listen to customer requests, develop new flavors, and do rounds of testing, interacting with customers again, attempting to quantify their opinions. They can use this data to target pretty specific customers.
You kind of get some neighborhood trends. One of a great example is we've made a flavor that I've made for several years. It's called Mango Rose Pistachio. So it's a mango-based ice cream with little rose water and blended pistachios stirred in. So it's a very Mediterranean, South Asian set of flavors. And we have a few locations that it does really well at. One is our Arboretum store, because that community. There's a lot of Mediterranean, southeastern families who live there, and so that's a kind of a more normal flavor to them. Our other location is our San Antonio store, which is right close to the Air Force Base, and a lot of the soldiers who have spent time overseas in Iraq and Afghanistan, the desserts that they enjoy while they're over there, a lot of the cuisine, rose water is kind of like the vanilla that's used. So while we put vanilla in everything, in all of our desserts here, rose water is very common there. So it's a flavor that candies and their baklavas and their treats and their ice creams and kheer all have a little rose water. So it's just kind of a happy little flavor. Again, desserts are kind of a happy treat. It's what people eat to celebrate the end of a meal. And so those two locations, those flavors are really appreciated out of those customer bases. Any other store that we send it to, it doesn't do that well. People, it's just different enough that people don't necessarily appreciate the rose water flavor. Even some of our, we know that at some of our stores that are in more like school and family areas, that candy and cookie and flavors that we named after Star Wars characters are going to do really well. And whereas some of our little more highbrow and flavors that are designed after signature cocktails are going to do better downtown, kind of near the bar district. So if we make we make a flavor called Tito is the Dude. It's made with Tito's vodka and it tastes like a White Russian, and it's a little more. It's a really delicious flavor, but it doesn't really sell well at a store right next to an elementary school. But it sells really well downtown in the entertainment district.
So ultimately, you're looking at the numbers and the data, and that tells you if you're serving your customers.
Mm-hmm. Absolutely. So it's if you ask customers what they want, they'll give you the. Again, sometimes it's just asking the questions, and sometimes it's even just seeing, wow, we sent that tub of ice cream there, and it disappeared in 4 hours. Whereas we sent a tub there that wasn't that popular at that location, and it sat there for 3 days.
By now, Joe described how Amy's already uses a lot of methods and technologies related to the engineering field. So I asked him if there was any new ice cream technology out there that he would like to see.
Of course, always just the more data we can get in, but it's sometimes the man hours of getting that data, of gathering the data, outweighs the benefits. So it's kind of knowing that balance of getting the data, and I spent 12 hours getting this data, and I'm only getting 1 hour worth out of it. So you want to make sure you're kind of spending your effort and spending your money in that direction. Could always like to find new ways to adapt new ingredients. So a lot of times it's just that information sharing, the culture sharing of how do you take a weird ingredient and find a fun way to present it out there. And beyond that, just better and more efficient, energy efficient freezer equipment. That's again, if the ice cream doesn't stay frozen, we're in trouble. So that's especially as
in Texas.
In Texas in the summer, better ACs, better insulation. That's always kind of what we like to look at and see.
So, future engineers, get working on that.
I like to tell people to kind of eat with their mind open and try new things. Again, there may be a flavor of ice cream that just sounds disgusting to you, but go ahead and give it a try. Those are the minds that I want, because, again, you never know when you're going to find that next great flavor.
To help solidify everything I heard from Joe, I spoke to engineering teacher and chemical engineer Melanie Kong. She's also a self-professed ice cream aficionado, so I thought she might have ideas on integrating this into the classroom.
One of the pathways that chemical engineers can go into is in food. That was actually something that I looked into. So I had worked for Procter & Gamble and consumer products, and I also interviewed at companies like Frito-Lay working and making consumer food. So food is definitely a viable option for chemical engineers out there.
What would chemical engineers do in like the ice cream production facility out there, the generic one?
So chemical engineers, the research and development chemical engineers would work on the lab scale ice cream testing. So how do we make more creamy ice cream? How do we get these flavors in there? And they'd work at maybe the scale that we would usually make ice cream in at home. Um, and they would figure out what is the best recipe at the lab scale. And then chemical engineers would also work on how, now that we have this perfect recipe that our research and development engineer worked on, how do we scale that up and make millions of tons of ice cream in our processing plant?
Sounds like a fun job. And
Yeah, I happen to know somebody who interned at Haagen-Dazs, and he was working in the strawberry cheesecake line, and he said he gained 15 pounds that summer.
they have like a division just for strawberry cheesecake.
Well, so it was in a pilot plant. So this is in between the lab scale and the full production
Okay.
facility. So it was in the in between line. And like during that time, you're just testing for, okay, what changes to the process should we make? Are these changes good for the ice cream? And you're probably just turning out one flavor just because you're testing the process and not necessarily the flavors. So yeah, strawberry cheesecake was there.
Oh, I can only imagine because they must have a division for vanilla and chocolate and like all these other
Yeah.
things.
Well, I'm sure that there's a whole bunch of design that goes around how do you schedule your batches? How do you clean out in between the different
Mm.
flavors? And how long does that take? How do you make as many batches as possible within a certain amount of time? So all of that stuff goes into plant design.
Would you say that even if you aren't an engineer, you might use engineering thinking in a lot of these
Yeah,
fields?
yeah, for sure. I would say that even if you're not an engineer, you would definitely be applying that thought process to your work. And I'm sure that Amy's did it. I'm sure that other ice cream facilities have done it where they're trying to figure out what is the best recipe, for instance, that would be a starting place. And I'm pretty sure that they have done lots of testing. And in
Mm.
their testing, they've probably varied some specific factors. They've varied the amount of cream, maybe. They varied their recipe, how much of the flavoring to add. And I'm pretty sure that they did that in a consistent manner in order to figure out what's the best recipe.
That's like
Or maybe they
exactly.
maybe they didn't,
Yeah,
but
no, but that's like
hopefully they.
exactly what Joe Morris said, like about testing and all that stuff.
Yeah, so I think that there's great engineering happening, even if they're not formally trained engineers.
Are kids and teens interested in ice cream?
I'm sure that kids and teens are interested in ice cream, or at least most of them are.
Even
Maybe
if
some of them are lactose intolerant.
I'm lactose intolerant, but I eat it anyway.
Okay, all
They
right.
they have lactate, which I'm sure some engineers were involved in making. Finally, I presented to Melanie the open-ended big design challenge that I talked about at the beginning. So the design challenge is this. It is hot in Austin, in Texas, and your ice cream company has lots of different locations around town. You need to get your ice cream to all your different ice cream parlors, even in horrible Austin traffic, without any of your ice cream melting or reducing in quality along the way. What kinds of things could you design to help you keep your ice cream in a good condition?
So gosh, as soon as you say that, I like immediately start thinking about things that are not related. But this kind of things makes me think about that last question about ice cream technologies. If you can maintain ice cream at the perfect eating temperature without it melting, that would be a new technology.
Hmm.
So maybe that would be a solution, is working on the formula itself and see if there is a way to have ice cream maintain that texture for longer. But so in what way are we supposed to take this challenge? Are we designing something that the ice cream is in? Are we designing the system?
So that was
Or,
purposely unsaid. So you're
Mhm.
right. You have options. You could change the
Okay.
formula. You could change the system.
So the things I'm seeing that we can change the ice cream itself. We can change what the ice cream is being carried in or saved in.
The truck, for example, could be designed, or like the container, or both.
Yes, or both, or the formula, or you can figure out a different way to. If it could just be optimizing the paths that you take to your different
Oh yeah, yeah,
distributions.
yeah. No, that's cool.
It could be a way that if you do it in series and maybe you like stash that ice cream in that other
Oh, you're
freezer for
right.
30
Yeah,
minutes and get that firm again before you keep on going. I don't know.
That's like the Uber challenge, trying to find the optimal path. No, that's cool.
But yeah, it reminds me of like, in computer science ones too. It's like, how many paths can you take to get between these few things? So
this is a nice open-ended problem.
yeah, definitely. It's definitely open-ended in terms of the kinds of solutions. So I think that in terms of what students might do with this, and do you see students learning anything from it? I think it would really depend on what you are trying to get them to learn.
Mm-hmm.
I've definitely seen cool lessons around heat transfer and like heat transfer, coefficients and different materials and conductivity of heat. So it would basically be a thermodynamics lesson where you would have to redesign the packaging of the ice cream and what kinds of materials would you use in order to create something that would keep heat in for longer or
Right. So if you're saying if you wanted to turn something like this into a lesson, if you wanted to turn this ice cream challenge into a lesson, you'd have to restrict it more so that the learning goals are more targeted?
I think it would depend on what class you're teaching. If you're teaching an engineering class and this might be like final design challenge and you just wanted to see how students approach the problem, it would be really cool to keep it open-ended and be really cool to see what are the different ways that you can approach this problem, what are the different ways that you can break apart this problem. Maybe it could be an exercise in systems where like, hey, you should work on the pathways, we're going to work on on the packaging itself. And I think in an open-ended class like engineering, where we might not have as many specific standards that we need to deliver on, that would be great. I think in classes like chemistry or physics, if there are specific learning targets, I think it would be a great problem. We would just have to narrow our design solutions.
Yeah, I'm glad you mentioned systems engineering as well, because I did not think of that at all. But that totally makes sense. Well, thank you, Melanie.
All right, thanks, Pius.
Now that you heard Melanie's thoughts on designing an ice cream distribution system and on related engineering lessons, let me know your thoughts too. Review the show on iTunes, connect on Twitter, or find me at k12engineering.net. Thanks to everyone who spoke to me for this episode, and thank you especially to Joe Morris of Amy's Ice Cream in Austin for the tour and talk. For links to videos of Amy's Ice Cream workers flipping balls of ice cream and doing other tricks, check out the show notes. You might get some ideas for physics lessons while contemplating the kinematics of cookies and cream. The views expressed in this podcast are not necessarily the opinions of any schools, companies, or other groups with which we might be connected. Our opening music comes from School Zone by the Honorable Sleaze. You can check them out on SoundCloud. Our closing music is from Late for School by Bleep Tour. Both are used under Creative Commons Attribution licenses. Thanks for listening. Hi, Rachel.
Hi again, Pius.
Some of you might remember Rachel from previous episodes of the podcast, and I just have a quick question for you, Rachel. What's your favorite ice cream flavor?
Oh my gosh. I have to pick one?
If you can.
Well, you know what? I'm all about... Some people are going to argue with me and be disappointed, but I'm going to tell you why this is.
Controversy.
I love vanilla. That was a high five.
Not a slap to the face. I love vanilla as well.
Here's why. It's incredibly versatile. It is a blank slate. It's the canvas of the Bob Ross. Yeah. Like, I'm Bob Ross painting a picture, only I'm actually just eating ice cream. But I could have caramel, or I could have strawberry, or I could have salted chocolate caramel, or I could have butterscotch, or I could have blueberry, or I could have a billion different things. But it all starts with vanilla.
I would say the same thing. That's my argument. I call it the rice of desserts. You can mix it with other things. But in a way, I do find it a cheating answer sometimes, like wishing for more wishes, because you're right. It is like the ice cream of all ice creams.
Except that, you know what? I honestly just enjoy a good bowl of plain vanilla ice cream as well.
I can get even more specific. The vanilla that I like is the milk-based icy French vanilla bean, or no, not French vanilla, sorry, just the vanilla bean ice cream.
When you can actually see the beans, the seeds in it, yes, I agree.
Right, and I don't like the yolk in it.
Nope, that's okay.
Oh, dang, I guess based on our previous episode,
It's a convergence.
We're in the
for
same
an
mind
ice
again.
cream
All right.
flavor.
On the count of three, what's your favorite ice cream?
One,
One, two,
two, three.
vanilla.
Vanilla.
All right.